Good day, everyone. Let's continue our discussion for part two of uh, our topic in Centroid. So, on the previous video, they terminate. So, the next step here is to solve for the centroid along the y-axis. So, sa akong gi-istorya sa previous nga kana video, the value for the centroid along y-axis is the same with the value of the centroid along the x-axis. So let's prove that one on the next slide. So again, follow the generalized formula for the centroid. We have here yt tapos total area equals since we already have a division for this complex figure, we already divide this one into simpler geometric shapes, and we arrived four geometric shapes. So we have y1 area 1 plus y2 area 2 plus y3 area 3 minus y4 area 4. We already know the value for the total area, so that is total area is equal to, from the previous slide, we have 6.107854. So 6.107854 square inches. Now the next step that we're going to do is to determine the values of the individual centroids of these areas along the y-axis, starting with the first object. Our first object is a rectangle. So the centroid of the rectangle is at the center, no? So mo na siya ato ang y1, y sub 1. Y sub 1 is just equal to, so kani diri ang apart, that is 1.5 inch. Next figure, so we have, from the previous slide, we have the triangle. The location of the triangle is right here. This is its location, centroid niya. This is our y2. Okay, so if we draw hidden lines here, adri ato ang centroid. So this one right here, this is, let's say, A, and A is just, again, since our centroid is closer, or our reference here is the base, not the vertex, so therefore that is 1/3 of the height of this triangle. So the height here is 1.5, so right here 1.5. So therefore our y sub 2 is just equal to this height right here, 1.5 plus 1/3 times 1.5. If you're going to calculate this, that is equal to 2 inches. What else? We also have our third figure. This is y, this is x, and we have here a square. So the center of the square, we label this one as y sub 3. Y sub 3 is just 1/2 of this height. Kani siya sa figure kani. That is 1.5 divided by 2. That is 2.25. Sorry. That is 1.5 divided by 2. So adalay ko ang iyahang true value. What else? We have the last one. We have the area of the ano, we have the quarter of a circle. Now sa quarter of a circle, its location is right here. So the centroid along x for quarter of a circle and also along y, they are both the same. So x here is equal to y. So y sub 4 is therefore the the value of the centroid along x, and we already solved that one from the previous slide. Saka na siya, this is x sub 4, which is 4r over 3 pi. So don't forget that one. So for r, our r is 1.5 over 3 pi. Okay, so substituting these values, the same thing with their individual areas that we have just solved, no, sa previous na slide. So we have y sub t is equals to y1 is 1.5, our area 1 is 3 times 1.5, then plus y sub 2 is 2 inches times our area 2 is 1 half times 1.5 square, plus y sub 3 is 1.5 divided by 2 multiplied by 1.5 square. This is the value for our area 3. 1.5 square plus we have our y sub 4, that is 4 times 1.5 over 3 pi, and then the area of this quarter of a circle, we have 1/4 pi tapos 1.5 square. And we're going to divide all of this by 6.107854. So we're going to use our scientific calculator. We have 1.5 times 3 times 1.5 plus 2 times 0.5 times 1.5 square plus 1.5 divided by 2 times 1.5 square plus 4 times 1.5 over 3 shift pi tapos 1/4. This is the area of the quarter of a circle, shift pi tapos 1.5 square divided by 6.107854. Okay, the answer is 1. That is 1.93. Okay, so answer na to is 1.93. Okay. This one right here, this is not addition, this is subtraction. Yeah, sorry, subtraction dili nga part. Okay, not addition but subtraction. So ato siya i-balik. So diri going back to our equation. Kani siya diri din siya plus kung dili minus. Okay, so the answer is 1.5656 or 1.566. So 1.566 inches. So therefore, final answer, we have 1.566 for x and 1.566 for y. Okay? Ato kitaon, same sila og values for both on the x direction and also in the y direction because the object is symmetrical with respect to its diagonal. No? Okay, let's proceed to example number 6. Locate the center of mass of the assembly that is along the along the z-axis only. Okay, along the z-axis only. Okay, masabtan naman pod nga they are symmetrical, no? Symmetrical with respect to the x-axis and also with respect to the y-axis. So that is why its centroid is at the origin. However, for the z-axis, ito naman siya height. So therefore, um, need siya i-locate ang centroid. Dili siya um, along the origin or at the origin, I mean. So mao nang ato siya pangitaon na nay mga given diri ang mga densities. We have 5 milligram megagram per cubic meter and 9 megagram per cubic meter for the cone. So unsa may atong gamiton ani nga principle. So this is for locating the center of mass, no? Sa atong mga discussion, centroid siya, but the idea still the same. So just multiply the center of mass and its weight. So if that is a center of the object, we call that one as the centroid. That is the product of the centroid times the length, that is for centroid of a line, and then centroid times the area if that is a centroid for plane figures, and then center times the volume if that is for calculating the centroid of a spatial figures or for solid objects. But for center of mass, so that is the product of the center of mass or the location of the center of mass times the weight. That is why we have here given densities. Okay, so since this is not uh, comprised only of one kanang simple nga solid object, so ato na siya i-break down. We use addition rule here. So this composite object can be broken down into a cylinder. Okay, a cylinder, of course, it has its known height z sub 1, and then it also has its density and of course volume. Ato siya i-label as rho 1 and v1. Now if we're going to add this one by another another solid, simple solid kaning cone niya. Okay, so the cone of course has its center of gravity. So location sa iyang center of gravity along the z-axis. We don't know that one. And of course, our cone has its own density and na po na siya corresponding volume. If we add these two, then we can generate our complex solid figure. May ana na siya. So it could be either here. No? So ano siya ikon as z sub t. Okay. Our general formula for this one, again, we use addition law. So we have z sub t, z sub t times the total weight, no, that is wt is equal to the sum of the products of the individual center of mass and weights. So we have z1 w1 plus z2 w2. But we all know that the total weight of this composite object is comprises of the weight for the cylinder denoted by W1 plus the weight of the cone. And remember sa inyo physics that the formula for weight is we have or mass, no? Or sige, weight na lang. So we have density 1, gravity times volume 1 plus for weight 2, so density 2 gravity constant V2. Okay, so that is your weight total. Now here we're going to solve first the Z1. The Z1 and also the volume of the first object, this cylinder right here. So solving for Z1 and the volume. Okay, so Z1, kung makita ng cylinder, very perfect, no? So ang center of the cylinder along its length or along Z1 is just equal to, okay, the Z1 right here is dili siya kutob sa iyang kuan. Kutob ni si Z1 centroid because kana akong gidenote mo na siya ang iyang height. So Z1 naras to nga. Okay, Z1. This is the height of the cylinder. So Z1 is just equal to 1/2 of the height. That is equal to 1/2, and our given height is 0.8. So 0.8 meters. That is equal to 0.4 meters. We already have a value for our Z1. What else? V1. So V1 again, formula for the volume of a cylinder. We have pi r squared times the height. That is pi. The radius of the cylinder is 0.2. So 0.2 squared times the height 0.8. Okay, so that is, if you're going to use your calculator, we have AC, so shift pi 0.2 square times 0.8. So we have 0.10053 na lang. So 0.10053, that is in cubic meter. Okay, we already solved the values for its center of mass and its volume. Okay, that is for the cylinder. Next is for the cone. Okay, for the cone, we're going to use integration there. So solving for the cone, the center of mass, and its volume. Now, let's start with the volume. Kaya ang volume, medyo easy siya solbon compared to the center of mass. For the volume, we have here V2. V2 is equal to, again, 1/3 times area of the base. The base area is this one. Okay, money base area. So that is 1/3 pi. Tapos 0.4 squared times the height of this cone is 0.6. Okay. So the answer here is 0.10053 cubic meter. Actually, same sila og volume ni cylinder, no? Sa previous nga slide, 0.10053 ang volume sa cylinder. Diri upward, 0.10053 ang volumes for the cone. Now, for its center of mass, or its centroid, actually, we need to use integration. Kaya gamito na to ayahang integration. So, ato ikuan nga mo siya ang cone, no? So, mo ang cone. This is y, this is x, and let's take a differential strip, no? A very thin strip. This is dy. Then we have here our x, syempre. And of course, this is our r, that is the radius of the base of the cone. And we also have its height h, and the location of its centroid along the y-axis, that is y. And then this one, of course, follows that this is h minus y. So here we're going to use the previous discussion no kadtong sa pagpangita sa centroid for special figures. The generalized formula for this one is again we have okay, today nakalimutan ang notation day ani kay dili y but z. Okay. Z ni siya. This is z, this is z, dz. Okay, so let's solve. Again, this is only for the cone, ha? Remember that in the figure, ang cone nato napababaw. Okay, so kung sa ato ma-solve dira gikan sa integration, that is just the z of a cone. But the total z, no, mamay, z2. Z2 is equal to height sa cylinder plus ZC. Okay, muna siya. Ang ato ang Z2. So, 3A, ato pangitaon si ZC. So, ZC times the volume, no? V2 is equal to the integral. Again, the concept here is like a very thin cylinder, no? So, muna siya yung differential area. Ipatuyok daw siya, no? Patuyok siya, anak, something like that. So, muna siya axis of rotation. The same thing with here, no? Axis of rotation gyapon. So, mura rin siya og cylinder with radius x, no? And then the height of the z. So, we have pi x squared tapos dz. And of course, don't forget to multiply the z here. So, z. From 0 to h yung height niya. After this one, we need to find an equation that relates the variable x and the variable z. Okay, dili man ta maka-integrate dayon ana. So use similar triangle. Ipato na siya i-cut, no, tas ati pahigda mo ni appearance. Okay, this is the strip. So this is the radius of the base, and then of course this is our height h, and then this one right here is x, and then this one is h minus y because this is y. I mean this is z. H minus z. From here, we can derive a relation. No? So we have the x over h minus z is equal to r all over the entire height h. So solving for x, we have x equals rh times h minus z. Okay. Now, plug in the values. So we have zc equals, we have pi integral 0 to h. So we have z times r over h squared times h minus z squared dz. We factor out nato si, okay, I forgot to write v2. So again, v2 is equal to 1/3 pi r squared times height. Ato lagi balik og suwat to kay magamit na sa atong pag derive diri via integration. So zc equals, at pagawas, we have pi times r over h squared. Then integral from 0 to h, we have z times h minus z squared dz. Okay, that is over our v2. We already have a value for our v2, so 0.10053 cubic meter. Here you can solve this one directly, no? Plug in the values, use your calculator, and kanang input this in integral expression. So press AC, shift pi, tapos the given radius is in meters, no, that is 0.4. So 0.4, this is for the cone. Cone man siya, over the height of the cone we have 0.6, and then square, tapos integral na, sorry, delete, integral of alpha x times, we have h of 0.6, so 0.6 minus alpha x squared, that is from 0 to a height of 0.6. Okay, tapos ang B2, so isuwat na to ang value for B2, we have 0.10053. Okay, so we have a z sub c value of almost 0.15, so 0.15. This is not yet the centroid of the cone with respect to the origin. We need to add this one by the height of the cylinder. Therefore, Z2 is equal to the height of the cylinder plus we have ZC. So that is 0.8 plus 0.15. We have 0.95. Okay, 0.95 meters. That is Z2. Now we already have Z2. We also have V2 and also Z1 and V1. Therefore, we can solve for the center of mass for this object. So we have again ZT equals, we have Z1 density 1 volume 1 plus Z sub 2 density 2 volume 2 divided by volume 1 V1 plus volume 2 V2. The acceleration due to gravity G was already been cancelled because sa numerator we also have G common to both terms as well as in the denominator. So mawala na to siya. In here, we can now substitute values. Again, ato na ko nga Z1 kay 0.4 man. Diba Z1 is 0.4. So we have 0.4. The density for the cylinder given, so 5 milligram per cubic meter. The volume is how many? Or how much? 0.10053. 0.10053 plus Z sub 2 is 0.95 multiplied by its density, we have 9. Tapos, the V2 is same, we have 0.10053 divided by, so density 1.5, volume 0.10053 plus, we have density 2, 9 times 0.10053. So therefore, the location of the center of mass for this one, gamit ang calculator, press AC, 0.4 times 5 times 0.10053 plus 0.95 times 9 times 0.10053, okay, divide by 0.10053 times 5 plus 9. Okay, so the answer is 0.7535 or 0.754. That is 0.754, and this one is in meters, so meters. Okay, so yung ganaon pag-solve og center of mass for composite objects just like this one with given densities. So that is the center of mass times the weight of the object. So ingon anara. Final lesson for this quant topic is all about the theorem of Pappus. So by the end of this lesson, you'll be able to apply the theorems of Pappus in determining the surface area and volume of a given composite figure. Okay, centroid of a composite figure, applying the theorems of Pappus. So let's start with the first proposition of Pappus. So for the first proposition of Pappus, the the goal here is to find the surface area of a certain figure that is being generated out of this given curve. So the first proposition states that the area of a surface of revolution equals the product of the length of the generating curve and the distance traveled by the centroid of the curve in generating the surface area. As you can see here in the figure, now we have a given length L, so defined or as indicated by this green color, and then it is rotated along this axis. No, nakarotate siya. That is why uh, it generates a surface area. Okay, it generates this surface area. Let's say, for example, if I have here on this 3D axis, no, assuming this is our axis of rotation, rotation. Now, if I have here a line, a straight line that is parallel to the axis of rotation, and then of course with known distance from that axis, and we're going to denote this one as r lang or r bar, the same thing in the figure. Now if I'm going to rotate this one, no, along this axis of rotation, what happens is it creates this surface, no, circular surface. Okay, it creates this circular surface, more like a hollow cylinder, a very thin cylinder. Okay, so na siya. And of course, not only that, we can also generate um, different surface areas out of different um, line configurations. You can have curved lines, straight lines, or any complex lines as long as it is a line. It is a one-dimensional entity. So again, we're going to rotate a line with respect to a certain axis, then we can generate an area, a surface area. Now, by using this theorem, the Pappus theorem, we can predict the surface area that is being generated by this line. So unsa man nato? Now the formula here is surface area, okay, is equal to the what? That is the circumference. No? The circumference times its radius. Okay. So to know its I mean the circumference times the line. Sorry. That is the circumference 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 times the length of the given line. The length of the given line. So what is the representation of the circumference from this uh, given figure? No? So the circumference is equal to, diba, that is pi d or 2 pi r. Okay? So 2 pi
r bar. R bar man given, and also in my illustration right here, R bar. So even if that is a very complex curve, so bisa pag complex curve pa na siya. Now the idea is we take a small cylinder, no, small strip. The same thing with this one. Ni-take siya og small strips, then iya siya or small line out from this larger line. So gamay lang, tapos iya nagi-rotate. So mo nang nagamit siya og integration, and by integration the resulting equation can be simplified into just the product of the circumference times the length of the line. So we have 2 pi r, that is the circumference, multiplied by the length of the line. So the length of the line here, we can represent that one as L. Okay, 2 pi r L. Again, this is the centroid. Okay, centroid of the line L, and this one right here is the length of the line L. Okay, so if you want to find the surface area of a curve that is, I mean, of this line, no, ngayon na generate, you can use this formula: circumference times the length of the line, 2 pi r times L. Inversely or conversely, if you want to know the centroid of this line given its surface area of revolution, then you can also do that by using this formula. For the second proposition of Pappus, it talks about the volume that is being generated from a given area. So lahi siya sa first. Ang first is ang line girotate in order to generate a surface area. Here, ang area, the entire area is rotated in order to generate a volume. So the second proposition states that the volume of a body of revolution equals the product of the generating area and the distance traveled by the centroid of the area in generating the volume. So ang diri say for example, we have here an illustration, and then this one right here is the axis of rotation, the axis of rotation. Now if we have a defined area right here, okay, so again, area is a plane, and this plane is parallel to the planar axis. And then if we're going to rotate this one along this axis, kaning naka-hidden line, so of course this area will generate a volume, no, mura siya og hollow cylinder. So mo-generate na siya og volume kay imo na siya gipa-rotate 60. So ana siya, okay, nalapas. So mo na siya ang iyahang na generate nga volume. So the same thing right here. This A represents the area of this shaded region. Okay, and it also applies the principle of integration, wherein nikuha lang siya og gamay, small increment of its area, yan nag-sum up, no? Yan nag-sum up. Now, nganong ni skip man kani siya nga theorem sa katong anto ang process, very lengthy process na integration. So diri iya na found out kay si Papos, found out niya nga instead of kanang having those lengthy nga integration, ang iyara is nag-focus siya sa centroid. Now, if the centroid is defined, then the volume that is being generated is just equal to the product, no? To the product of the circumference times the area. So that is the volume is equal to the circumference 2 pi r. Again, r here is the what? The distance from the center or from the centroid of the given area towards the axis of rotation. So if that is known, then you can directly solve for the volume of the object that is being generated without having those lengthy uh, integration. So 2 pi r bar times the area. Okay, so again, r centroid of the given area. The given area, and of course, A is the area. Now, nagkalahian lang, again, second proposition, if it is volume. So, we still have here the term for the circumference. And then the last one is for area. If that is area, then the resulting object or the resulting entity is volume. However, for circumference times the length, the resulting entity is surface area. Okay. So, mara na inyo tigamaan, kani siya iyang gipa-simplified nga dili lang mo mag-agi og integration as long as you know the centroid of that particular area for the second proposition. And then, if you know the length of that particular entity for the first proposition of Upapos. Again, first proposition talks about the surface area. So we're going to use this equation, surface area equals the circumference, 2 pi r, wherein this r is not the radius of any circle, but the centroid of the line, and times the length. For the second proposition, talks about volume, that is circumference times the area. And for the circumference, the same thing, 2 pi r, wherein r is again not the radius of a given circle, but the centroid of the given area. Let's have our final example. Here, determine the surface area and the volume of the solid formed by revolving the shaded area 360 degrees about the z-axis. So this is our z-axis, that is our axis of rotation, and we have here our area as well as its sides, no? The outline of this object. Now, if we're going to rotate this one, ang ma-generate niya is not only a surface area but also a volume because it has its defined area. So, unsa may maka-generate ani og surface? So, we have this one right here, this side, and also this side, and also this side, maka-generate siya og bottom surface, and also this one, kani nga side, maka-generate siya og inner surface. So let's start with solving for the surface area of this figure. So surface area. Ato siya i-illustrate balik. Let's say this is our z-axis. And this is our given plane figure. Okay. So mag-assign ta og kanani lines. So first we have our line number 1, this vertical line. This is the location of its centroid. We also have this slant line. This is the location of its centroid. Tunga jud. This is L2. And then this one, locations and centroid. This is L3. And then finally, we have L4. Okay. Kada tagsa-tagsa ani ka mga linya, ato ni siya ipang rotate. The same thing sa akong gidiscuss kaganiha nga if we have this one, axis of rotation, if we have a line, ato siya ipang rotate tagsa-tagsa in order to generate a surface area. So maunang gamit gyapon diri ang addition property. Now, from the figure, the second line, which is this one kaning slant line, wala siya na defined, no? So ato sa ibutan diri the L2 here just equal to the hypotenuse, no? Pwede mo ta makahimo diri og line. So ma-triangle na ni siya. So therefore that is the square root of the height of this triangle, which is equal to 1.2 square plus the base, that is 0.9. Okay, so our L to the I, so we have AC square root 1.2 square plus 0.9 square. So the answer is 1.5. So 1.5 meters. So na. For the other lines, okay, we can solve their values right away because the dimensions are defined. So again, the combined surface area of these four lines can be solved using this expanded form of the equation 2 pi, okay, r1 l1, because this is the surface area generated by the first line plus the surface area generated by the second line plus the surface area generated by the third line, and finally surface area generated by the fourth line. Okay, diri walay problema ang mga lengths because very obvious we can just kanang ano ato lang kitaon, makita raman nato sa figure. Ang challenge diri kay ang center nila, ang center aning mga lines. Let's start with R1. The figure, this is line 1. So the distance of this line kani kay diri man ta mo rotate. So we're talking about the x. This is x1. Okay? So since niigo man siya aning kaning 1.5, no, mo man ang center niya. So our R1 is 1.5. How about for R2? For the line 2, katunga siya. Nasa between ani. Okay? Nasa in between ani. So therefore, our x2 is just equal to x1 plus, no? That is 1.5 plus 0.9 divide by 2 kay katunga man siya ana. So aton siya i-simplify. That's equal to 1.95 meters. For R3. So our R3 kani mo na siya tong line number 3. So si line number 3 mo na siya x3 kani. So that is 1.5 plus 0.9 lang. That is equal to 2.4. And finally, we have R4. R4 is just the same with R2. Okay, R4 is just equal to R2, which is equal to 1.95 meters. Okay, so yun ana lang. And after that, plug in the values. So the surface area, we can factor out 2 pi kay common man siya for all terms. We have R1 1.5, tapos the length of line 1 is 1.5 plus 1.2, so 1.5 plus 1.2 plus R2 is 1.95 times the length of R2 is 1.5 plus R3 is 2.4, the length of R3 is 1.5, and then plus R4 we have 1.95, and the length of R4 is 0.9. Okay, so therefore the surface area of this figure would be 2 shift pi tapos 1.5 times 1.5 plus 1.2 plus 1.95 times 1.5 plus 2.4 times 1.5 plus 1.95 times 0.9. Okay, the answer is 77.47 square meters. So 77.47 square meters. So this is the surface area that was or that is being generated by this shaded area. Now next, let's proceed to the volume. So number 2, yung volume. For the volume, so let's draw again the shaded area. So this is our z-axis, the axis of rotation. Now, the shaded area can be broken down into two simpler figures. We have first the triangle, no, and then the second one we have this rectangle. So it has its defined centroids for the rectangle. Nasa di sa center and the triangle na ako diri ang apart. So again, ito drawing. We have the triangle na ading ang centroid. And we have here the rectangle na adri ang iyahang centroid. So we have area 1 for the triangle, area 2 for the rectangle. And then of course for area 2, it has its centroid R1. And also for area 1, its centroid is R2. Again, nonsense na ako magkuha tag centroid with respect to the z-axis. It's because ang atong kuha nga centroid should be perpendicular to the axis of rotation. Mo na niya tigaman, kailangan perpendicular lang sa axis of rotation. So the formula for the volume using second proposition of Pappus, we have again the circumference 2 pi r1 starting with the first, okay, actually bali no, this is area 2, this is area 1. So 2 pi r1, the centroid of the first area times the magnitude of area 1, and then plus 2 pi r2 times the magnitude of the second area. For r1, no, so our r1 based on this figure, that is 1.5. This is our r1, that is 1.5 plus half of 0.9. 0.9 divided by 2, so that is equal to 1.95 meters. For R2, for our triangle, so this is our R2. Kana siya. So our R2 is equal to 1.5 muna plus kumikitaon, this is the centroid, this is the base, and we consider this one as the height. So therefore, since our centroid is closer to the base, we take 1/3 of the height. Now the height is equal to 0.9. So we have 0.9. Okay. So if we're going to solve this one, using a calculator, AC, 1.5 plus 1/3 times 0.9. So the answer is line number 5 or 1.8 meters. Now, how about the areas? So for area 1, very simple. We have length times width, so 0.9 times 1.5. And also for area 2, we have 1/2 the base. So you can have either of these two sides because both are perpendicular to each other. So we have 0.9 times the height of 1.2. Therefore, our volume is equal to 2 pi. Pwede na natin ma-factor out. R1 is 1.95. Area 1 is 0.9 by 1.5 plus R2 1.8 times area to 1 half 0.9 by 1.2. So therefore, our volume is equal to, butang dito sa pikas, 2 shift pi, tapos 1.95 times 0.9 times 1.5 plus 1.8 times 0.5 for 1 half, tapos 0.9 times 1.2. Okay, so the answer is 22.65. So the volume that is being generated by this figure is equal to 22.65 cubic meter. Okay, so that's it. Thank you for watching and may God bless you.